Good. So now that the most important part is out of the way, let's talk about the research topic. So I will talk about two parts, or do this talk in two parts. The first part is talking about text-to-process extraction. So that is a general task to go from textual descriptions or text in general to process models. Talk about what it is, also why it's hard. And the second part, I will present a paper we recently published at Kaiser 2026, which is about trying to use also small language models for this text-to-process extraction task, because LLMs are maybe not always the answer, or maybe not always needed for everything. And yeah, as I already told some of you, I said 2 weeks ago, I sat watching this paper being presented by the first author, and it's been a while since we worked on it. It was like, okay, this is an interesting topic for SummerSOC. Also connects with yesterday's talk. So, Francesco, tomorrow we talk about sustainability, and this also plays a bit of a role here. So I think it fits well. So first of all, what are we talking about in general? So in a broader sense, so I'm from the research area called business process management. I was just thinking about it ahead of this talk. I only agree with one of these three words, because when we talk about businesses, I rather talk about organizations, because they don't always have to be businesses. And management, well, I feel it's more than that, because I'm also coming from computer science, sort of computer science, so management may also not be the right term, but this is what we are living with. The process is the key part. In a broad sense, this business process management, so it's a broad discipline that generally analyzes how work is performed in organizations with many different goals, but you can kind of summarize that, say, okay, we try to ensure consistent outcomes and trying to make use of improvement opportunities. A lot of it is just figuring out what is actually going on. I think that's always the first step. We're a broad discipline, and well, in different senses, it's multidisciplinary, but also broad in terms of what we consider as processes. So we are not talking about just one type of process, but in general, we can talk about processes involving physical products like manufacturing or logistics. We just saw in Wolfgang's talk, that's where your tokens cannot simply be duplicated, where they can disappear or be moved around, so to say. But we can also talk about services, for instance, where we generally have data, so far non-quantum data, so there it's easy to make a copy or something like this. So also these more digital processes are also well studied. And as said, yeah, business process management, it's not all about businesses, it's every organization is running on processes. So we can also look at other application domains, like healthcare, for instance, where the focus is, at least should not only be about optimizing for costs, but also trying to improve the quality of care, etc. So we talk about processes in a broad sense, also generally can be from enterprise to sort of small or medium-sized companies. So every company or every organization, I should say, is running on processes. Some of them do this in a more explicit way, others are doing it more implicitly. Maybe they don't even know they have processes, but in the end, they are sort of everywhere. So we also use a very broad definition for what a process, or you call a business process, is, where we just say, okay, it is something that consists of multiple steps, so that is always key. So it's not just one thing you do, but generally we talk about a chain of related activities, events, and decisions, etc., what we just saw also before in transitions. Usually we talk about processes that also involve multiple actors, maybe multiple systems, etc., so that there is some kind of sense of complexity, that it's not just studying one person sitting behind their laptop, but generally that it's really like a collaborative process. And a process is something that also provides some kind of output that is of value to an organization or its customers. So there should be something coming out of it. There's also something going out of it. But we're in the modeling day. Modeling is a key part of business process management, and there are different notations for that. Some of these are wrong, obviously, Wolfgang. So I think what we use in process mining very often, or what customers in commercial settings use in process mining is this very basic representation called a process map or a directly follows graph, where we just capture what are the steps in a process and we can show how often these steps follow each other. So there are no clear semantics here. You cannot really execute these, so there are also better representations, like one we have just seen. So for instance, the workflow net capturing here the same process as you see here, but here making, for instance, explicit where do we have concurrency, where do we have a loop, where do you have an exclusive choice, which is actually very hard to discern from this process map here. And then there are other notations like BPMN, which you could say to some extent sits a bit on top of this, which is generally more used in the business domain for communication, etc., because there's more expressiveness. These are rather simple examples. So if we talk about, for instance, BPMN in organizational settings, I mean, this is still an example from the study book, but yeah, things start to get a bit more complex. So we have, first of all, we have processes involving a lot of steps. In practice, they will be even larger or maybe split up into sub-processes. We have a lot of different kinds of informations. For instance, what we see here, probably you cannot read it, but we have some division of who, of sort of the organizational perspective. So we capture who is performing which steps in the process. So we have here steps done by the ERP system, here steps by the warehouse staff, and here steps by sales. So we also see which part of an organization is responsible for these things. We have, so that captures the organizational perspective. We can capture the data perspective to indicate where you have data objects, databases, etc. So there are all kinds of things that you could capture in such a BPMN model. So that is very nice, of course. So there's a reason these models are created in organizations. So there are all kinds of use cases. So first of all, generally they can be used for communication, so they can serve sort of a shared language, and also very often as sort of a bridge between, for instance, the business and the IT side to represent how should the organizational side work, and then how should that be supported by IT processes, for instance. They can be used for analysis, so also a BPMN model, or at least certain aspects of it we can translate, for instance, into workflow nets. We can do all kinds of formal analysis on them, and also if we have sort of data behind it, which is the concept of process mining, then we can also locate bottlenecks, we can look for compliance issues, etc. They serve as a basis for redesign and improvement. So once you know how the current process is working, you can look at this and see, okay, where could we maybe get rid of these bottlenecks and make things operate better. And also BPMN, so there is also potential to turn this into something that's executable. We can try to automate processes, etc. So overall, there are good reasons to have process models, especially if they're actually correct and capturing reality, which is sort of an aspect in itself. However, just like we talked about, I heard it several times this week already, nobody wants to program anymore and things like this. I think we can also talk about this in the same way when it comes to modeling. So I think people or organizations really like to have models, but yeah, who wants to or who can actually make these models? Okay, here is the font size. Not the one I wanted to use. Good. Yeah, so first of all, so establishing process models, especially taking back this complex one or even more complex one that I showed a couple slides ago, is very time consuming and also a complex task. It's also, what is very important, it's not just about creating the model, but you also need to figure out what do I want to put in the model. And that is something that's typically also not, this knowledge is generally not held by the same person who can also create such a model. So people working in an organization, they may be able to express what they do, how they conduct their work, how processes run, but they may not have this capability to come up with these models that look like this, because not everyone speaks this language, so to say.
Well, in practice, these models are generated in a hierarchical manner. on BPMN, for example, we have 3 different layers of modeling. With domain experts, you start very simple, then you refine it with other experts.
Yeah.
Okay.
So in general, you also don't build that up from the. Yes, but in general, yes. You need this sort of interplay between people who know how the process works and between people who know how to model. So what then also happens is indeed we start either by creating simple models or also by first of all capturing information, not immediately in this process model format, but also it's often described in more accessible formats. And of course, text is something that everyone can create and can read. And also organizations often already have a lot of information on their processes captured in text. So even if they're not explicitly describing a process model or describing how a process works, there may be all kinds of documents, work instructions, regulations, etc. that provide information on how a process works or how it should work. And now, of course, in the age of AI, everyone is starting to get used to chatting to things, so it's becoming more and more natural to think, okay, I just write down how my process works and I would like to get the process out of this. So yeah, this topic is becoming more and more relevant, or also more and more in line with how we are conducting a lot of our work, similar to instead of programming, also more and more typing. Here. The downside, of course, of having text and all these things is that these are not as usable for these things I mentioned on the previous slide. So when it comes to communication, especially between business and IT, you may want to have a process model with sort of, well, I wouldn't say completely defined semantics, but at least it is more precise than sort of what you can get in a text. For sure, you cannot do any formal analysis of compliance or something from a text, etc. So for the downstream use cases, we still would really like to have a model. It's just that we prefer not to model, or at least reduce the amount of time we spend modeling, just like we want to reduce the amount of time we spend on programming.
But it isn't the most heavy argument executability and enforcement. If you have only a textual description, you would like to turn this into something executable, and why do you want to have executable? Because you want to enforce that the process is executed in exactly the manner that has been described, because you spend a lot of time in optimizing the processes and so on. Formal analysis sounds academic.
Yeah,
so, you know what I mean?
Yeah, formal is
executability, because you want to enforce exactly how a car is manufactured.
Yeah. No. So formal is especially also typically not talking in an organizational setting like formalizing in the form of patronage, but capturing in, let's say, more structured way that text. Yeah, good. So therefore we come to this general task of text-to-process extraction, or text-to-process model extraction, that does not flow as nicely, where we try to take these textual resources and try to turn this into a process model, or at least to extract what is the process described in our text from there. So the input can be anything that is natural language that relates to processes. So today we'll mainly talk about textual process descriptions. So these are really sort of already process-oriented documents, where here there's a very nicely structured example that shows, okay, sort of step-by-step how a process could work. Say, okay, a small company manufactures customized bicycles. Whenever the sales department receives an order, a new process insert is created, a member of the sales department can then reject or accept the order for the customized bike, etc. Everyone can read this, can understand it. And then what we try to do in text-to-process extraction is to generate some kind of process model out of this that captures the process that is being described here. There are techniques for imperative process models like BPMN that really describe what should be done. There's also work on declarative process modeling, which is more talking about the boundaries, so the constraints that a process should adhere to. And yeah, so different target languages. And essentially by doing this, we try to bridge the gap between how processes are described, or how domain experts can talk about how they do their work, and how they can be then also analyzed and executed or enforced in organizations. This is a rather well studied but also hard problem, as you can imagine. So text can be anything that maybe sometimes happens to talk about it. process. So they can, text can occur in all kinds of shapes and forms. Some of them are really process-oriented, like this is already very structured in a process-oriented way, but you may also just have some kind of guidebook that happens to relate a bit to how processes works. You have different writing styles, so you can do BPMN in different ways, but imagine you can write text in all kinds of different ways from different perspectives, etc. So it's very, very varied. And on top of that, so text can also be ambiguous, or you can actually have incomplete descriptions of a process without realizing it, because your text maybe looks fine, but then once you try to turn it into a model, you think, okay, wait, I didn't specify what happens if we have a choice in the process, or if we only specified what happens in the positive case, I didn't make explicit what happens in the negative case. Maybe that's just sort of obvious to the person who created it, but for a model you need to capture this. Good. So it's a rather difficult problem that received already quite some attention some time ago. I think the earliest works were like 2012, 13, and when I started my PhD a little bit afterwards, I also started to look into this, and back then we were doing very much rule-based work. So for those who ever did any NLP, back then we had like the Stanford parser and Stanford core NLP, which provided grammatical relations between words, and then I was programming Java for half a year just to figure out, okay, where do we mention an activity and how does that relate to the object, and things like this. It was very rewarding when it then worked out. So that's how I also started, and how I had to convince people that, actually people like to write about processes in text. These days, I don't have to convince people that they try to prompt anymore, so to say. And from there we then had the natural development, as you can expect, more to machine learning models, and of course more recently also to large language models that can now do things better than I spent my 6 months back then doing on. You can now do that in 6 seconds, for instance. I should speed up a little bit. For this task, there are two general ways of how to extract a model. There's sort of direct and two-step transformation. So direct transformation would just be, we have a text, we ask an LLM, generate a BPMN model, and we are done. There's also a lot of work in this two-step transformation approach, where we first sort of create a world model, or first analyze the text to extract all the entities and relations, etc., essentially the elements that we would need to generate a model. Let's first have this in some kind of intermediate representation, and then we can build a process model or a diagram in sort of deterministic algorithms, or we can explicitly recognize where do we have ambiguity, where are we missing things, etc. This two-step transformation, this has all kinds of benefits in my view. First of all, it breaks down a rather complex problem into subtasks. So subtask 1 is what in the NLP domain is called named entity recognition, is where you analyze a text and you try to recognize the aspects of interest to us and see what the roles are. So here we have a lot of different defined types of entities, like we have activities, we have actors, etc. So we can here see, I hope it's readable, we have activities like sends, records, is sent, we have actors involved, etc. So we tag the text to see, okay, what is happening in there. And then the natural task afterwards is then called relation extraction, where we try to link these elements to each other. Where, for instance, we can recognize a use relation where we see that, okay, this sends here sends a questionnaire. We have an actor-performer relation which captures that this sends is performed by the customer office, and a receiver relation which captures that send goes to the claimant. So we split up this problem essentially. So this then has several benefits. So first of all, especially if you think about language models, we would use language models for what they're good at, which is analyzing text, while leaving sort of the model generation step to more dedicated algorithms, can be deterministic algorithms. So we use LLMs or language models for this part, where they're good at, but once we have these, you don't need an LLM to figure out how to turn something like this into a model. This we can just do here. It makes sort of the process model extraction task agnostic to the target modeling language. If you're trying to look for these things, we don't care yet. Do we want a DPMN model? Do we want a battery net or something like this? Do we want a declarative notation? We just see, okay, what is actually included in the text. And what is nice is it breaks up the problem into well-defined natural language processing tasks, like named entity recognition and relation extraction, as I just showed, but also, for instance, there's call reference resolution, where you try to recognize when you have references like it or he or something like this, and how that relates to there. But these are tasks that are well known in NLP, so you can use also existing NLP solutions for these things instead of handcraft, something like this. And what I think is the main benefit also in this talk here is that breaking up this general task of going from a text to a process model allows us to also evaluate performance in a clearer way, because we can evaluate the performance of an approach on each subtask separately. For instance, again, it's the gold standard, making it possible to compare extraction approaches. While if you just have approaches that directly discover a process model from a text, you may have two different process models that are equally good. It's very hard to compare them, so you may get into subjective judgments, while by splitting up the problem we can get into sort of objective assessment. So this is where we are. And then what I briefly wanted to show was this recent work that was presented at the Kaiser conference a few weeks ago in beautiful Verona. It is mostly work driven by Julian Neuberger, a postdoc at DTU, so the Technical University of Denmark, but I found the idea very interesting, and I think worth briefly touching upon is here. And so the title of the work is Enabling Small Language Models for Text-to-Process Extraction, Balancing Accuracy and Efficiency Through Distant Supervision. So first of all, as a justification, we already had several discussions this week, so hopefully I can get you on board that we may not always want to use LLMs for everything, even though they're obviously good at this text extraction task. So that is not a concern here. But what is a concern is, for instance, privacy and compliance. We talk about organizational processes, we talk about sensitive information that tells perhaps possibly in detail how an organization is doing its work. There are some stories of privacy leaks, for instance, especially if you use cloud LLMs, you're losing kind of track of where your data goes. An alternative is then to use in-house LLMs, of course, but this comes, for instance, with large hardware costs, so this may not be feasible for everyone, especially if you want to have really the strong performance that cloud LLMs can provide. And also in terms of sustainability, well, we all flew to Greece to attend the conference, but still, we should also consider what the usage of LLMs is doing, especially for, that's the point of the talk I want to give, especially using LLMs for things where we shouldn't need them, or that's maybe the culprit. So there are different reasons for why what we propose is more this approach here, where we have in-house in a company, we train a small language model on some process repository. So we train a small language model that can then be employed just on consumer hardware, so no specific servers needed, etc., that then can be used to tackle this task. Good. Hopefully everyone is involved. Good. That sounds, of course, very nice. The catch is, of course, that to get these smaller language models to a sort of reasonable performance, or maybe rivaling performance of large language models, we need data to train them. So we're talking about, for instance, fine-tuning models like BERT for those who know other kinds of approaches. So these are smaller machine learning models, or smaller language models, that can be trained. For instance, we can train a model on this relation extraction task, we can train a model on this named entity recognition task. But for that we need data, and this is data in the process domain we generally lack, or there's, let's say, very little data available for that. creating such data. So what we would need are textual process descriptions that are annotated with all these things I showed before, with all of these colors, or the entities, the relations. I was involved in establishing what's called the PET data set, so process extraction to text data set, where we did this for 45 texts with me and 2 colleagues. I don't want to talk about how much time that costs, how many discussions that cost, etc. So this is not a task that we would like to do. Plus you also need texts that are suitable for that. So, and that just gave us 45 texts. Well, for these models, we're talking more about hundreds or preferably thousands of annotated texts that we need. So we're not just talking about we need process descriptions, but we need process descriptions that are annotated with what we want to extract. So to overcome that, what we did is we turned to distant supervision. I'm not sure how familiar this term is. Distant supervision is an idea in machine learning where you automatically generate large amounts of labeled training data. So in a way, so also a bit related to what Francesco was talking about. Typically, for instance, stemming from knowledge bases or something like this. And what it's essentially doing is it's saying, okay, we can generate a lot of data. It won't be perfect, it will be noisy, etc. But we just essentially generate so much data that a bit of noise is fine. So in that sense, it bypasses this expensive and also really boring manual labeling that we would otherwise have to do, but at the risk of some kind of quality. But still, we found it very interesting to investigate how far could that get us to train a small language model. So traditionally, this is done, for instance, from knowledge bases that you can then turn into textual descriptions, you can annotate, etc. But here, what we want to have are annotated textual process descriptions, and things we do have are large repositories of process models, so actually sort of the target where we would like to go. So what we do, or what we did, is we used LLMs to automatically turn process models into textual descriptions, and then to annotate these texts also with LLMs with the necessary labels, so creating large amounts of training data.
I'm missing the point. What is the format in which the process models are available?
For instance, a BPMN already. So we have large repositories, for instance, from SAP with 100,000 models. Yeah. So we start from a process model. I was really good. So here I'm still mentioning LLMs, right? But the key difference is that we run the LLMs just once to create data, and this can be done on sort of these public data sets. Doesn't have to come from our own organization. In order to generate training data, and then afterwards we get our trained models, so we never have to use LLMs for inference or for sensitive data, etc.
I'm using the large language model here for generation. Is it a big one or a small one?
Yeah, here there are the bigger ones used. Yeah. So here this can be done once. Unfortunately, due to licensing, we cannot share the data we generated this for this paper, but you can run this essentially once and then train also multiple language models. So I will show you a bit more. So this is the general idea, that we create a lot of training data, where the first idea is to just, okay, we give an LLM, we give a BPMN model, and we ask it to describe that. That was also our first thought, probably not worth writing a paper about, but let's see. The problem is that we then got descriptions, or very often we get sort of leaks of modeling jargon into the text. So we get descriptions like, okay, next there is an XOR gateway with 2 paths, or things like this. This is not how anybody writes. If you ask someone, how are you doing your work, you don't say, well, in the morning I have an XOR gateway, and then I either make coffee or the alternate path. This is not what we would like to have here. And then of course, then if you have training data like this is not going to work. So we want to have descriptions that are natural, but also to make sure that they are complete, so that they are really representative of this here. So therefore, our idea was to make things a bit more sophisticated. So we start from our process models. In this case, we use a repository of BPMN models that we then first describe in a controlled language. So using SBVR. This is a structured English way of describing processes. In this case, some very unnatural descriptions of a process, but in text. And then we use LLMs to rephrase these into these natural language descriptions here. Then we use an LLM to annotate these, and then we can train our smaller language models. I will speed up a little bit. So this description of these controlled measures looks something like this. So there are all kinds of patterns. You can capture sequences, splits, etc. This has been well defined. So if we have an input process model, we derive different kinds of patterns from that, or different rules captured in this SBVR language. So here we have a rule that says it is obligatory that production, the actor checks stock after the process starts. This is a really grammatically terrible sentence, of course, but with this notation we know that, okay, we need to have process start and then we need to have checks. And we can turn a whole process model into these rules, so it's not just one rule, but many of these. Then you get a very hard to read process description that is all with it is obligatory that, things like this. So then in the second step, we take this list of rules essentially, and we use an LLM to rephrase that, where we turn this into a so-called style transfer task, where we gave it sort of descriptions of different forms, so from different domains, like we have handbook styles of describing processes, but you can also have processes described in more of a legal way, or maybe you have in your own organization your own style, so it can sort of learn how processes are being described in your context if you would like, or in our case we generated different styles, and then we can turn these texts we have into different text. So there we get, after the process starts, the production department checks the stock of materials. Very nicely readable here. And by having these rules and translating all these rules, as I said before, we make sure that we have a complete description of the process model in there. Here. From there, we can then automatically annotate this text that we have generated with these entities and these relations that I showed before. We did some technical tricks to make sure this annotation is better, because we know that also LLMs are not perfect annotators, but still we can help them, especially because we know the ground truth. We know how the annotation should look because we came from these controlled descriptions. So we know, for instance, what are the activities that should be annotated. So when generating this training data, we can already say, look, this text for sure has this activity check stock, so look for it even if you have some creativity. And that really improved the annotation accuracy, as we found here. There are still some mistakes here, so this annotation starts to look rather complex, as you can imagine, but overall it worked quite well. Good. And then, so this then gave us this large collection of synthetic training data. We used several thousand models for that, so getting several thousand training examples. And then the nice thing is we can use that, once you have that data, you can use that to train also different small language models, maybe with different tweaks or different focuses or whatever you would like to do it, or maybe later you figure out, I want to use another model. You already have the training data, so you don't have to do all of this again here. So I'm starting with the question, or concluding with the question I started with. So did it actually work? So we performed evaluation experiments where in the end we selected 4,500 models, rather restricted. There are apparently more than 1 million BPMN models in this repository. There's a lot of overlap, a lot of poor quality models, so we were rather restrictive in selecting models. We generated data.
How did you select them? Is this criteria?
Yeah, we have different criteria, like the labels should be English, not just A, B, etc.
Yes.
They should be sound, etc. So we were rather restrictive. If we loosen them, then in the paper we have a list of explicit criteria. Then indeed, so we use GPT-5 for this data generation and annotation, and when we tested 2 models for entity recognition and 2 models for relation extraction, and sort of the general NLP techniques for that. And then we used the real world or this PET data set for evaluation. So we didn't use our synthetically noisy data as the test set, of course. We used handcrafted evaluation data set. So in short, for the entity extraction task, we really rivaled, or the small language models could really rival or even outperform the large language models much faster, so the time per document was very low, and we also measured energy consumption, where the energy consumed was really a fraction, especially of the larger language models. Here for GPT-4, this is an estimation, but here for Llama, for instance, we could see, okay, we were using 7.7 versus 0.12, for instance. So the differences were significant, while the performance here was actually very good. The relation extraction task, this is a bit more complicated task. There I have to admit we did not get exactly the performance of at least the top performing model, so this was GPT-4o. Back there, so that achieved an accuracy or F1 of 91%, while we managed still to get up to 83%, but still it was almost as good as, for instance, Llama, with 70 billion parameters, doing better than the smaller Llama models, which performed really poorly. And again, the energy consumption, memory, or especially the energy consumption, is hugely different, or much better here. So here, maybe not performing at the top, but definitely performing as well as sort of the open source large language models that you could host on your own large infrastructure. We were coming very close there. Good. So in general, that works. We did evaluation studies. This slide I wanted to skip, so to make sure we have all our 3 hours of lunch, or almost all our 3 hours. We have some threats to validity, so we only tested 4 as small language models. We did not yet do really hyperparameter tuning, so maybe actually we can even increase our performance a bit on the technical side for those dealing with energy measurement. Yeah, we used a library for measuring the energy consumption, which is known to have, or yeah, it's not as precise as doing direct hardware readings, but we try to get as close as possible. And of course, for everything we use the same setup. And I do have to admit that also for evaluation or testing, we only have these 45 descriptions. So now we have a lot of training data, but we would still like to have more evaluation data. Good. So the answer is probably we don't need large language models, or definitely not. Always some small locally trained models can approach the performance of LLMs for this task without the cost of using large language models in the cloud or on-premise with expensive hardware. I think very importantly without the privacy risk while we're dealing with sensitive organizational information, and also with the lower energy footprint here. Good. So use LLMs where you truly need them. Try to find other solutions in other parts. That's it. Thank you very much.
Thanks a lot. Questions? Yeah.
So, I think let's put it provocatively, is this sort of the last attempt of the NLP people to tell us that we, obviously I was late, so I didn't get a full stop, so makes good. No, I think, and I think that my background is we're at the moment discussing, we have an electron intelligent user interface where we have NLP basics, and we're discussing whether we throw it out. Now seeing that paper, it sort of, did not push me either way, because as you're not getting close to what current models get. And you make the energy argument and basically the privacy argument. I think they're both sort of, I get them in a way, but we have seen sort of also the decrease in energy using, especially on the side of inference. So I think that the question is not so. And I think also your energy calculation does not include the energy you have to use to build your
Yeah,
system, which I think is, if I have a large language model, I can use it for everything. If I build a small language model for each process I have, which I use 3 times a year, then so I think, what is your sort of, let's put 3 years, fast forward. Basically, we have now seen 3 years of language models, and basically, typically we are trailing those models that run on Olama. Their performance trails something like 12 months of the top models. So do you believe in 3 years you would still make this argument?
Well, in general, I'm not making the argument that it's strong. So I fully agree with most of the comments. I do want to clarify, you don't need to do this for every process, right? So this is, so if this is a task that you frequently do, then you can have your dedicated modeler. Yeah, how things are moving, and in general, this is the issue with this any LLM research here that things will move away. So for us, this was now the test, also really on the training side. I've also done research on, let's say, fine-tuning or instruction tuning LLMs, which I also find very interesting to see how that works. But yeah, you don't know if in 2 years that any of these conclusions work. So I'm also not an NLP person, and none of the authors here are. So this was for us more as from the BPM community. Okay, the interest of how far can we get, but I won't advocate for okay, we will never use LLMs, especially if the cost goes lower, if you can also run them, and you see that also with phones, etc. So decades ago, we would also have never said, okay, you can run what we're doing now on your consumer-grade laptop. So also maybe in a couple of years, this argument of, okay, you need to buy servers to run these local LLMs, this may also go away. So I fully, I'm also not a non-LLM advocate at all. So.
And now a less provocative one. I think you showed the evaluation, and I think we discussed at the moment what are good evaluations and what do percentages mean. Do you have for processes an idea basically what the difference is? Because we know in certain areas if you're basically 1% better, nobody's using the other model. In other areas we have seen where 10% don't matter. Do you think when you look at this, are there gold standards for evaluation that really work, or is it very, or should we not even attempt to find them because it's so process specific?
Yeah. No, so these are on a data set that have different processes. I think the real issues here is that this is based on a relatively low number of documents, or not even relative, on just a low number of documents. So we have roughly 45 descriptions here, while other NLP tasks are evaluated on thousands or millions of documents. I think that is the main issue here. Of course, F1 score always hides things, but that is also just for space saving here. I do think this is already better, as I mentioned before, than how this text-to-process extraction is sometimes evaluated, where people have a model that was once created by a human and then compare how the automatically generated model compares to that, because there is so much about preferences in there. So I think at least this split up into this named entity recognition, relation extraction, there is still a bit of bias, especially when texts are ambiguous, but this took out at least a large part of the bias already. But yeah, these differences, yeah, more is better. What is a deal breaker? So is it 83% versus 91%? Yeah, that I find hard to admit. This is also, we are not as developed as in the NLP or the computer vision community, where it's so clear what these numbers sort of mean, or what a 1% gain means. And actually, we started this annotation of this pet data set, and we started with the goal of trying to move a little bit towards that, because before it was sort of the Wild West of everyone was just doing something different, and then also claiming, oh, we are the first to generate VPMN with this flavor, so we cannot compare to anything else, and then and now at least you can compare. So we're making as I think often in our field maybe and also other fields, we're making small steps to sort of catch up with the larger communities. So, but all very fair questions.
Is there another small question, please?
Actually, it's not a small question, but no, actually I like the idea. We had this paper a couple of years ago, the BPM before, where we basically did natural language process transformation. And actually at that time, models, large language models, were not very good with BPMN. The reason why we used instead of BPMN another graphical language, which is MemNet, but which is a limited part of BPMN. So it's I find approach I think completely reasonable and I like it a lot. I have a couple of questions. My first question is how much of the BPMN format is Mario covering? For example, covering the speed lanes, message passing, or things like this, or are you only covering, let's say, only comparative part of the lanes?
Yeah. So we are we're basing this on this this pet annotation schema. I mean, I was also involved in this, but this was led by Chiara Guidini and Patricia Bellan. So from FBK, there we propose this annotation scheme. It covers activities, events, gateways, also roles. So we do get the organizational perspective. So from there you can also derive, so for share pools and swim lanes, and a bit of message passing, because we capture also who is the recipient of things. There was also work by colleagues, I think also Julian Neuberger, so the first author, or sorry, didn't put his name. They also worked on sort of an extension of the annotation schema to also capture, I think, data relations, etc. So they have a bit more
So
expertise.
you're pretty much covering the entire BPMN, even though in the end you don't know how much you evaluated of that.
Yeah, I mean, nobody covers everything, just like UML, there's 1,000 pages, I think BPMN also has at least 300. But I think we cover the main, let's say, process perspectives, but not all the, not.
And a second very small question, instead is a more technical one. Why in the evaluation you use also the 7 billion parameters of LAMA, which is usually considered the intermediate version, let's say? Because you skip from the 3 billion one to the 70 billion.
Yeah.
So maybe the 7 billion one was kind of.
I don't dare to, so I can ask Julian, but that on these decisions I'm honestly
I
just not
think
sure.
it's something interesting to check, because from my experience, the 7 billion version is much better than
Okay,
the
yeah.
version. Of course, it doesn't have the performance of the one, but it's usually considered a good, let's say, midway.
Okay. I think one reason maybe that, also in research there's sometimes constraints, so I think, I mean, I don't know.
That's fine.
That's good.
Thank you.
Okay, I don't see any other questions, so thank you again. Well, we convene at 3 o'clock for a fantastic second part of modeling. Thank you.
Before we leave, the people in the steering committee should stay here. If you don't know whether you're in the steering committee, you have a problem.